Hello everyone, in this video I will be discussing vector subspaces. So before I discuss the vector subspaces and before you start watching this video, quick thing I want to share with you that these videos are not very polished in the sense of language frame etc. But if you sit and watch this video with copy and pen and more importantly alert mind, you will definitely learn a good mathematical style. Videos here are not made for any competitive, so there won't be any trick. Okay, so how to solve this, how to solve that? No, there won't be any trick. Rather, focus will be mathematical side, mathematical thinking, improve your mathematical thinking along with the linear algebra. So a vector subspace. Before I start the vector subspace, so suppose you have given, we start from a vector space. Suppose this is a vector space and it's a vector space. This is a vector space over R, and you have given that W is a subset of V. Just subset. Do you know subset? Every element here is an element here. W is a subset of V. Now the question is, or more, if you are comfortable with this equality, okay, so I will put this equality, but here but this much is enough actually. W is a subset of V. Now we will define the induced operation on W. Induced operation on W. Induced operation on W. So V is a vector space, so V has two operations. One is scalar multiplication and other is vector addition. So we will define the induced operation on W. What does that mean? So you have, suppose you have W1 and W2, W1 and W2 in W. So since W is a subset of V, this implies that W1 comma W2, W1 and W2 lies in V, and then V is a vector space, so there is a plus, there is a vector addition. So we can talk about W1 plus W2. So this is a plus from this V, this lies in V. So basically this may not lie in W, but this lies in V, but we can talk about plus. So given any W1 W2, there is a meaning of W1 plus W2. What do you mean by meaning? Because you have an addition here, so there is addition here, vector addition here. So this addition, I am adding these W1 and W2 as element in V, not an element in W. So this is the induced operation on W. We call the first induced operation on W called the vector addition on, and then the second is if you have alpha belongs to R and W belongs to W. So I will think this W belongs to W, not in W, in V. So this, since W is a subset of V, so I can, so I will think this W belongs to W as a W belongs to V, and then here I can talk about alpha into V in V. I can talk means this is some element in V. So you can talk about, sorry, here I will also put W. You can talk about alpha dot W. You can talk about W1 W2. See, these lies in V. Why does this lies in V? Yes, this lies in V because this is a vector space. This is a vector space. So vector space is closed under vector addition and the scalar multiplication. But this never says that this must lie in W. So these are two operations. These are called the induced operation. And now comes the, now we are having the definition. W is a subset of V. W is a subset of V, and V is a vector space. Is said to be a subspace of V. Subspace, people write vector subspace, vector subspace of V if W itself is a vector space with induced operations. So this is very important. I will again focus here. If W itself a vector space with induced operation is a subspace. Pause the video and just try to understand the definition. Definition of what? Induced operation in the in the subspace. Sometimes people say this is a vector subspace. Vector subspace. If you understood, I will see. We'll see with an example whether you understood or not. So first of all, I will go very non-intuitive, very it's not good example, but definition you will understand with the help of this symbol. So let us take R, usual real number, with the real number addition, the real number multiplication, and then it turns out that this is a vector space. R is a vector space over R. Now let me call W. Let me take W equal to 1. W equal to 1. So question is and let me define one operation on W. I will define one operation on W. So W has only one element, so I'm going to define 1. This new plus I'm going to define, not the black plus, red plus. W1 plus 1 equal to 1. This I'm defining double dot equal to 1, and I'm going to define for every alpha belongs to R, alpha into 1 equal to 1. This is the new, this is the new plus, and this is the new scalar multiplication on W. This is the new plus and new scalar multiplication on W. Now with this new plus and new scalar multiplication, the question is W comma this new plus, I will put here, I will write here using red, this new plus, and then this new, this, if W is a vector space over R. Just check it, pause the video, think carefully, just check it. Vector space over R means what? Vector space over R means what? It must satisfy all those 8 axioms, A, B, 1, 2, 3, 4, 5, 6, 7, 8, you know, 4 for the addition, 4 for the vector scalar multiplication, and how the scalar multiplication behave with the addition, and then the so now whether this is a vector space or not. So answer after pausing the video, if you answer is yes, it is a vector space over R, and W is a subset. W is a subset of R or not? W is a subset of R. Answer is yes. So this W is a vector space, and this W is a subset. Now the question is whether W is a subspace of R. The question is this, whether the W is a subspace of this R, this vector space. So once someone is asking this question, there are a lot of hidden things he did not mention. One is R with respect to this addition, this scalar multiplication. Now W is a subspace of R or not? So let's go back to the definition. What is your answer? Pause the video, give the answer, and then go back to the definition with me. W subset V is said to be subspace if W itself a vector space. So W is a vector space. We have proved W is a vector space. So now the answer of this question is, what do you feel? Yes? No? Answer is no. No. Why answer is no? Because W is a vector space. Because W is a vector space, that's okay. But vector space with respect to induced operation or not? No, this operation is not induced. This operation is not induced. So we had to check whether W is a vector space in the induced operation or not. Just check it. So what is the induced operation? In the induced operation, what do you mean by what is 1 plus 1? Can you tell me? This plus, not the red one plus, this plus, this is equal to 2, because 1 I will think W induced operation, I have to think this element in R, and then I will have to see. So whether this lies in W or not, this doesn't lie in the W, because W is just a singleton 1. So therefore W is not closed under vector addition, induced vector addition. Here is induced vector. So this implies W is not subspace of R comma plus comma dot. So I think this example is quite this example, I really like this example. You understood this example. The definition is here, example is here, everything is in one frame. I try to give you here. Again I will mention induced operation is very much important. That may be vector space, subset may be vector space in some other operation, but whether in induced operation it is a vector space or not. Okay, I hope you understood this one. Pause the video and rewind everything till you understand, and if you understood, let me ask few questions. Let me ask some question. Question number one is let W comma plus comma dot. Now I will not write this, I will just say let W is a subspace of V. Then W is a subspace of V. Then what is then see, first of all, before I write the question, W is a subspace of V. This means I'm giving you W is a vector space over R with respect to induced operation. So there must be, so whether 0W belongs to W or not. Yes, good. Next thing is whether 0V belongs to V or not. Yes. Now the next question is whether 0V belongs to W or not. What is your answer? Given W is a subspace, what is your answer? Pause the video. Answer is yes. Why? There are a lot of proof. I will just write quick proof using one of the property of vector space. Since V is a vector space, V comma plus comma dot. Now I'm not writing because it is clear. Here we are writing plus comma dot and same operation. Operation is fixed now in this calculation. So this is the reason I did not mention the operation. So since V is a vector space, so therefore we know one property. What is the property? You take some alpha real number and then or you take 0 is in the real number and then you multiplied any vector in V. So where should that lie? That must lie in V, and W is similarly W is a vector space, so that should lie in W. Why? W is a subspace, so this means that W is a vector space, so therefore 0 into W has to lie in W. But what is 0 into W? Whether this is the 0V or not? Why this is 0V? Since W belongs to W is a subset of V, this implies that W belongs to V. So by using property 1, 0 into W equal to 0V. And similarly, W is a subspace, W is a vector space, so 0 into W equal to 0W. So basically we did just not prove 0V belongs to W. What we have proved that 0V equal to 0W equal and everything belongs to W. So W is a subspace, then the 0th element in W has to be equal to 0th element in V. This is the look like very obvious because but if you think that W is any abstract vector space, then it is not that much direct. So pause the video. This one is really very important property. And similarly, can I write this thing? I'm writing one thing. W is a subspace of V, then number 1, 0V belongs to W. Is this correct or not? Yes, good. This is yes. Okay. Number two, if you take any W1 and W2, whether for every W1 and W2 whether W1 plus W2 lies in W or not? Yes or no? Answer is yes. Why? Because W is a subspace. Number third, if you take any alpha belongs to R and W belongs to W, whether alpha into W belongs to W or not? Answer is yes. Why it is yes? Because W is a subspace. This means, so W is a subspace of V, then these three are automatically satisfy subspace because it is a vector space with respect to induced operation. These operations are coming from V. This we have proved just now. 0V belongs to W. I may ask other way. If you have as W, if W is a subset of V, we are not starting from subspace, the subset of V satisfying above 1, 2, 3. W is a subset of V satisfying above 1, 2, 3. Then we can prove, we can ask then whether W is a subspace of V. Then we can ask. And just pause the video and try to understand the question. And answer is to this one is yes. And just see, this is very useful criteria. Very useful criteria. If W is a subspace, then these three things satisfies, and if these three things satisfies, then W has to be subspace. This is very important. Quick. How to prove? We'll come to the proof. But suppose you know this, to check whether W is a subspace or not, subspace of V or not, we just check these three things. We just check these three things, and then we will then we are done. Proof of this thing is very simple. One way we have proved this part is we have proved, then we have to prove this. If 1, 2, 3 satisfies, then W is a subspace. So can you tell me what does that mean? If 1, 2, 3 satisfies, then W is a subspace. What does that mean? So if we want to prove that W is a subspace, so whether A is true or not, A means what? Whether W is a closed under vector addition. Yes. B is true or not. If you do not know A and B, you just watch the previous video, properties of vector spaces, I have mentioned there. So W, B is or not. What is B? B is, W has to be closed under vector scalar multiplication. This is true because it is given. C is true or not. Just listen the proof of C. This trick you have to understand, how to go from subspace to vector space, and then bring down the vector space result to the subspace. So C, what is C? W1 comma W2 belongs to W. What we have to prove? That W1 plus W2 equal to W2 plus W1. So I started from W1 plus W2 belongs to be. Next immediately go to the vector space. And what does vector space says? That this implies that W1 comma W2 belongs to V, because W is a subset of V. Subset is given to you. And then since V is, now use a big fact, since V comma plus comma dot is a vector space, this therefore W1 W2 belongs to V. We have W1 plus W2 equal to W2 plus W. See, I started from element in W. I proved that W1 plus W2 equal to W1 W2 plus W. Where did I prove? I proved in V. That's okay, but these lies in W because W is a closed under vector addition. So these are equal in W. So we have proved. This is not C. This is number 1. Similarly, suppose if I want to prove the number 4, what is the fourth one? Given W belongs to W, we have to find some W1 belongs to W such that W1 plus W1 equal to 0 W. This we have to prove. So now listen the proof of this one. Understand, please try to understand. Proof is given in any text, but why I am explaining is this fact is really important. See, every time you go from W to V, here also you start W belongs to W, You say that this implies W belongs to V. W से V पे गए, and then now use something. There exists some W1 belongs to V, because V is a vector space such that W plus W1 equal to 0V. Yes, and now we have to prove that. We have to prove that there exists some W1 belongs to W. What we get? What we get? There exists W1 belongs to V, such that W plus W1 equal to 0V. But we have to prove this. So now there are many ways to prove. Such W1 is equal to minus W, you know, and minus W is equal to minus 1 into W, and minus 1 into W is minus 1 is a scalar, W belongs to W. So use the property that W is a closed under, W satisfies 1, 2, 3. So therefore this has to be in W. So see, I started from W, go to V, found some W1 in V, and from here I landed again to that W1 has to be in W. So given V, I found W1 lies in W such that W plus W1 equal to 0V, but we know that 0V equal to 0W. So we have found. This is not easy. If you should take time to understand, assimilate these steps. These steps are really important. If what do you mean by subspace? Of course, in induced operation, and then W subset V is a subspace of V if and only if number 1, 0V belongs to W, number 2, W is a closed under vector addition, and number 3, and what is number 3? W is closed under scalar multiplication. This is what we have done in this video. Slowly watch again, and if you have any other problem, please write an email, comment, and please feel free to give suggestion. Okay, thank you.